Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today, I think it's going to be a pretty fun video because I'm going to present a new scope that I think you guys might like. And I'm also going to demonstrate it. So I'm going to try to show you the features as we go along, okay? I have a flyback converter here. It's a offline converter, so it means it comes off the AC power line and it converts down to, I think it's what, 12 volt output? So I did a video on this. I started doing a video series on this. I'm going to talk about how to design one of these and troubleshoot whatever. But in this video, what I want to do is I want to use this to look at real signals with an oscilloscope to show you the benefits of the really cool scopes today and how they work. Okay, so first of all, let me just show you this. All right, so I have this little camera here, and I'm just going to show you just what the board looks like, okay? Input power, EMI filter, rectifier, volt capacitor, and main switching FET, control chip, main transformer out, main diode out, volt capacitors, and the output, okay? So, got the climb meter looking at the output, got the amp probe looking at the input, and I'm going to be using this McSig up here. And I'm going to show you that on the remote, okay? So I'm going to show you the McSig first. It's a great scope, okay? Here, let me turn this guy off. Sorry, I had a little interruption here. Gracie is alone tonight, and so she wanted to come see me. Okay, hopefully she won't get electrocuted. No, I'm joking. Anyways, all right, so yeah, Gracie, just sorry. Okay, sorry guys. All right, so what I want to do is first of all talk about what makes a great scope great and why it's worth the kind of money I'm talking about. What I look for is I've done a couple scope videos before, like how to pick a scope, what's the best scope for this price, that price. This is the best scope under $1,000. I know that's a lot of money, but for you guys maybe interested in that or interested in some of these other scopes, just looking to see how they work, I'm going to show you some things, okay? The scope behind me over here is a Siglent. I bought that when I started this channel because I was going to build my bench back up. I had sold my other scopes, which was a Tektronix 2465, which I loved. And I also sold a Tektronix 2430. I sold them, some years ago because I was moving around and stuff. And I knew I was going to buy an updated scope. I didn't actually think I was going to buy a digital scope. I thought I just might buy the new updated Tektronix. But some years went by and here I am. So I looked at YouTube videos like you guys are doing right now. And I saw Rigo scopes and Siglent scopes kind of meeting that price range. And so I got this one on sale. It was $4.99. It was because of this damaged box, so it was a good deal. It's the SDS 1202X, so 200 meg scope, and a 1 million point FFT, which was a big selling point. It also comes with the decode and stuff. You don't have to buy the scope and then buy all these upgrades, which kind of kills me that these scope manufacturers do that stuff, right? Because it's all built into the hardware. Why don't they just turn them on? Anyway, so I bought the Siglent. I found a problem with the FFT and I notified them. I'd been in communication, the guy was a really nice guy, kind of swapping information. I mean, they're not about supporting a small channel like this, but they did loan me an active load one time, so that was nice of them. And unfortunately, I had to send it back. I had a lot of questions. I couldn't really demonstrate anything more because I had to send it back. Anyway, all right, so they said they don't make that scope anymore. They replaced it with the X-E scopes, right? So I had a chance to work with one of those scopes at this place, and wow, you could tell the firmware was written by someone else, and I think it was kind of jacked up. I didn't really like it, and so that's probably why they didn't want to update this one. Maybe the guy who wrote this wasn't around anymore. Anyway, so that's one of the things you get with the benchtop scope. I mean, even with my Tektronix, I had to send it to them to get it repaired once. That was super expensive, but I didn't know, you know, anyways, one of those things. So then I bought this GWN stack. That was $1,800. A lot of money. 4 channels, where this one back here's a 2 channels. So I got 4 channels. Again, 1 million points FFT, which is awesome. And I've done some videos on FFT to show you how to use those if you want to check the links down below. Okay, so it also has a really cool, what they call MDO. Okay guys, so the MDO, mixed domain, that means it has both the time domain like any other oscilloscope, but it also has a frequency domain like the FFT. So, but they call it a spectrum analyzer mode, where it looks like a spectrum analyzer the way you set it up, so it's way easier than like this Siglent. When I was messing around, and the MixSig's a little bit easier, but you know, there's just a lot of setup stuff, right? And you have to readjust things every time you change the time base and things like that. Where the spectrum analyzer feature, it's really just an elaborate FFT in there, but it acts like a spectrum analyzer, and it's really cool. So it also does Bode plots, which you may have seen on the channel. You may have seen all these things on the channel. But I had a viewer suggest that I look at Picotech, the Picoscopes from Picotech. So I got a hold of them, and I was never really a big fan of USB-based scopes, so I never even looked at them when I was buying these scopes. Oh, and I bought the MixSig after that. So, and I didn't buy this one. The one I bought's over here. MixSig sent me this one. This is a new one. They gave me this one. The other one I bought. But then I bought the MixSig because it's portable battery. It's just really cool. It's kind of a replacement, I think, for that Tektronix THS 720 up there, or 730A up there. I need to start selling some of the stuff, right? Anyway, so I got this one, you know, for the channel and that, because updated scope and so on. But yeah, I never even considered USB-based scope. So got a hold of Picotech. They said they'd loan me one. I said thank you, and I chose a 4444. Has 4 differential input channels. Super cool, super unique scope. So I got that, and man, I just like fell in love with the USB-based scope after that. I was like, wow, this is super cool. And I'm going to show you why in this video. But I just thought, wow, that is awesome. So then some time went by, and I thought, you know, I should do a review of their 5555, which is more of a general purpose scope, more like this. 4 channels, has generator output, and that kind of thing. So I asked them if they'd loan me one. And by the way, that 4444, after they loaned it to me, and I did a couple videos, they said, why don't you just keep it? So I was like, thank you, Picotech. So I didn't want to ask them to give me another scope, so I asked them to loan me one. They said, we're going to give it to you. So I was like, thank you, Picotech. So I feel super lucky that I got those scopes, because those are by far the most expensive things I got up to that point. And then Omicron sent me something just to give them a thank you. So, and I'm going to show that a lot more in the channel. So the Picotech, I have one of them right underneath here, the 5555, okay? And the 444 it's in a plastic box that it comes with. It's really nice. It's a whole kit. Anyway, those scopes are like $2,000 and $3,000, okay? So when I was thinking about doing a scope for under $1,000, what's the best scope you get under $1,000? And why would I think that you need a better scope than what I have here? Well, so let's talk about that right now, okay? I'm going to show you a signal here, okay? Okay, guys, so I'm hooked up to this scope with my iPad. You can do it with the phone as well. So, see? You're going to see it on the screen. I'm going to pop it up here. But what you're looking at is just a bunch of purple, yellow, smushy stuff. It doesn't even look like a lot. But if you look on top, this is 5 milliseconds per division, okay? And the reason I'm doing that, you can see up there at the top corner maybe, it says 282 kilohertz. So there's a signal in there that's switching at 282 kilohertz. And what it is it's a switching power supply, okay? It's this flyback converter. And the reason you can't really see the signal right now is I'm looking for low frequency ripple, that 60 hertz, 120 hertz coming from, you know, this kind of thing. So from the AC power. So I'm looking to see that. Right now I don't have much of a load on it, so there's not very much ripple, but you can see a little bit, right? You can see it there at the top. All right, so now check this out. One of the big features that sets these new scopes apart from, like, say, my old Tektronix 2430, that digital scope that I used to have that wasn't really that great of a scope because they didn't have these features. So today's digital scopes are awesome. They replace analog scopes, okay? In my humble opinion, they replace them. So one of the reasons how they did it is they have to capture so many samples, right? Nyquist theorem says at least 2 per cycle so they can rebuild. It's really, most scopes you'll find, they really do about 2.5, at least 2.5. Because if it's only 2, you could be doing the crossing point every time. So theoretically it can be 2, but it can't be, it has to be offset from the crossing point. Anyway, 2.5 cycles does that. All right, so here, let me expand this. I'm hitting the little thing down the bottom showing I want less waves so you see I'm 20 microseconds. You can start seeing the waveform. Look at that. You can start seeing the waveform now, right? The other cool thing about this is you can actually see the ringing and the spike, all this stuff going on. You're like, holy smokes, what's all that stuff? So we were like looking at low frequency stuff, and now I'm down at 500 nanoseconds per division. I'm looking at rising edge, falling edges. I'm looking at high frequency switching and these and this ringing, right? So I can see all that kind of detail. I can take measurements. I can do all kinds of stuff, and that is super cool. So that is one of the features that all these scopes have. They all have deep memory. The Sigma, I kind of forget what the Sigma has now. I think it's like, when you're using both channels, I think it's 7 meg per channel. I think it's 14 meg total. And that guy up there's 10 meg per channel. It's independent 10 meg per channel, no matter what, if you have 1 channel or 4 channels on, okay? This guy, if you have 2 channels on, it's 35. If you have a single channel, it's 70. And here, I'll just show it to you. I'll pull it down. So you can see 70 to the left, 35 we have, and you can see it notated up at top, and then 17.5 if you have all 4 channels. And I have that selected because I wanted to force it to grab all those points instead of putting it on auto. Auto works great, but I just wanted to force it, okay? So, all right, that's one of the main features of these scopes, is that they have deep memory. So, and this MIG-SIG has crazy deep memory. Well, the one I'm going to show you has even deeper memory than this, okay? It's crazy. So horizontal resolution is awesome, right? So you can capture things, you can trigger things, and that's one thing I want to talk about is trigger. So horizontal, now vertical, you can see the top waveform, the yellow one, 50 volts per division. Okay, so 50 volts per division means that I have 10 divisions up, so I got 500 volts I can look at. This is an 8-bit scope. All these scopes are 8-bit scopes, okay? 8-bit scopes are the most, I mean, until you spend some money, usually over a few $1,000s, you're going to get a 8-bit scope, okay? So 8-bit scopes means that you break up the vertical resolution into 256 steps. And so what that means, at 500 volts, it's 1.95 volts about, okay? So, yeah, you get 1.95 volts resolution. It's like, so, doesn't sound awesome, right? And if you're looking at the top of the waveform, now that I zoomed it out, you can almost see it. Now, I'm going to recapture this waveform, with it spread out, so we have awesome horizontal resolution, so that's not a question, okay? If we didn't have this awesome resolution, here, watch, I'll show you. If I keep on going out, and I'm going to put, here, I'll put this ringing stuff right here in the middle of the screen. And then I'll keep spreading this out. I wonder if I can. Yeah, I can. Okay, so 2 nanoseconds, you can see there's kind of like, it almost looks like staircase now. You can kind of see what I'm talking about, so getting a little chunky, right? So we're starting to lose the horizontal resolution. But, I mean, this is pretty amazing that we can do this. Now, if you had one of these scopes and you really wanted to zoom in on this, you would zoom in, trigger, and capture that waveform. But because we have the deep memory, we can look at both things, zoom in, come out, zoom in another section, because at low frequency you can see different things, and maybe you're not this low frequency, but you can change things and you can move around and do things. So that's what's awesome about the deep memory, okay? All right, so now here, whoops, I moved waveforms around. That's okay, they're fine. Here, I'll put that guy back on that grid. So I like to put the 0 points on grids so you can count from a grid, right? But I'm just demonstrating some right now. And if we want to see the time between those traces, you can see that, right? I didn't show you that, but look, you can see the fall times, the difference between those two things. So, all right, so I just want to show you that. Oh, and by the way, the yellow one, okay, that yellow waveform we're looking at, sorry, I forgot to even tell you what it was. It's a drain of the FET, okay? So it's the drain of the FET, and what's happening is, it's switching on and off. And so we're seeing it go up to like some pretty high voltage, right? I mean, the peak to peak is 259 volts. I don't have that coming in from here. We're at 120 volts, but it gets doubled and then a little bit more. Okay, that's the way they work. I'm not going to go into that, but that's what we're looking at. The purple waveform is on the other side of the transformer. I'm using differential probes over here. If you go back and look at the picture, you can see the differential probes. But I'm using differential probes, and I'm looking. So then I can look at I can have a primary ground on the yellow, secondary ground on the purple. Okay, so that's what I'm looking at, and I'm looking at the transformer side over there, and it's got some ringing. The primary side looks pretty darn good, pretty nice and smooth. And stick around for my next video on this flyback, and I'll talk about that, okay? But yeah, this is pretty cool stuff. Okay, so let's go ahead and recapture this so we can even get, I'm going to recapture at 1 microsecond, so we'll get some really cool stuff, okay? Hold on a sec. I'll play it safe, okay? You never know, right? Okay, so what I'm going to do is I have to start running the scope again. Okay, it's running. And then I'm going to bring, I think I'm going to bring the voltage up. Oh, okay, turn on the switch. Now I can bring it up. I turn everything off, turn it down, turn it off, and everything just keeps it safe. Okay, we're going to see it trigger pretty soon. There it goes. Now notice the trigger kind of jumping around. I'm going to talk about that here in a second too. Okay, I'm going to freeze that waveform. Got some meters shutting off on me over here. I thought I had them turned on so they wouldn't shut off, but sorry. That's what all that beeping is. So does it look any better, any cleaner? I mean, now that I captured it close up instead of zoomed out. Look at that. I still captured all that data. And you know why? Because I forced those samples, right? So it caught the samples I'm looking at and it went out and grabbed more. But anyway, so there's the waveform. Okay. That's what we're looking at. All right. So that triggering, you saw how it's moving around. You guys been in the lab enough. You know what I'm getting to here, right? I'm going to go to this. I'm going to go to the trigger menu right here, and well, here, I guess I could just do it from the iPad here. So, okay, now the source is channel 1, the yellow one, nice clean rising waveform. So why does it jump around? There's a little bit of jitter, because it's regulating, so it's changing the clock cycle every time. It's not consistently the same duty cycle. So it's the power supply doing power supply stuff. So I'm looking at channel 1, but it's moving around. I'm looking at rising edge. You can see the edge, rising edge. Couple. It's DC coupled. All right. So I could try to AC couple it. I could high frequency, low frequency, or noise reject. You guys know that, right? So you go click one of those until it locks in. Hopefully it locks in on one. Sometimes you have to move the trigger point a little bit higher, a little bit lower in the waveform because maybe it captures it better there. So you know what I'm talking about. You have to kind of play games with the trigger sometimes to get it locked in, right? All right, so keep that in mind when I show you this other scope. Okay, so And that's not just a MIG-SIG, that's pretty much any scope, right? So anyway, they're analog triggers, they're not digital triggers, which that's what we're going to talk about. All right, so horizontal resolution, triggering. There's really three main things of the scope, and then there's the vertical resolution, okay? We talked about that, 8 bits, 1.95 volts, okay? Now, what I want to do is I capture this yellow one, and I want to look at the top of it. The way this circuit works is it smooths off that top. Instead of having a ring, instead of looking like the purple one, it makes it look like what we see in the yellow one. That's the beauty of this kind of circuit that I'm looking at. All right, so I'm going to grab this yellow one and the purple one, I guess, and I'm going to pull them down the screen, because what I'm going to do is I'm going to expand, okay? Here, let me pull it down, and you can already see what's happening. I'll do the yellow one too, because it's nice and clean, but we'll zoom in on both of them, okay? And I'm pulling the cursor down. Well, you can see the yellow one, okay? I'll spread it out a little bit. So we're just looking at the top of the waveform there. Yeah, you see how chunky it is? It's vertical resolution. And you can see the purple one's doing that too, right? So if I zoom in a little bit more, yeah, you see that? If I zoom in this way, it becomes more and more apparent. Like you can see the steps of resolution there, right? So we're kind of losing things. And anyway, I don't know how much of this I need to do to get the point. I think you guys got the point already, right? You can see those steps right there. And this is 5 volts per. Remember I said 1.95? You see there's about almost 3 steps within a division. So that's kind of what we're talking about. Here, let me get this guy. Okay, I'm going to get the bottom of this waveform just so you can kind of see it, if I can keep control of this guy. Okay, so there's the peaks. Every time I hit this, it takes me a minute to find it. But anyway, you can kind of see the peaks there, right? Okay, I'm kind of beating this point to death, but you can kind of see the chunky steps. So that's the vertical resolution. That's the 8 bits. So now you've seen what it looks like on an 8-bit scope with a lot of memory. I mean, awesome scope. It's just, you know, yeah, the trigger, there's just not a whole lot of option. I mean, you know, there's options on the triggers, right? But I'm going to show you some other things, okay? So it's time to pull out the other scope. Okay, guys, so it's time to pull out the other scope, and this is it. Now, pretty simple box. There's not much to it, right? What I like about that is they don't waste a lot of money on packaging. It kind of goes along with the theory of the USB scope. With the USB scope, you don't have to have a display, obviously. You have a smaller case, obviously. Smaller power supply, because you're not running. I mean, a lot of that power is in the display and the drivers for it, and the GPU, the general, the processing unit that has to process all the stuff that's going on that screen, right? So all that stuff is going to take place on your laptop, my MacBook over here, okay? And this will run on PCs or MacBook. My MacBook actually has Parallels program, so I can run PCs or Mac side by side, no problem, no problems at all. Runs perfect. So, okay, guys, I'm going to show you what's inside this scope, okay? We're going to do a little box opening. I'm going to pull this. Okay, guys, so I'm going to show you on this little camera here, just a little box opening right here. Look, hey, I love it. Recycle. So awesome. That's all there is to it. Pretty simple box, right? And inside, we have our user guide. Okay. There's your user guide. It's, by the way, it's different languages. Most of this stuff, I mean, this is pretty simple setup stuff that they talk about here. But you can get all this stuff online, right? You're going to want to go online and download the software anyway. So there is the scope. Look at that. channels A, B, C, D, and it shows you that little chassis ground right here, because all these metal things are tied together, so just be aware of that. And they're tied to your USB right here. So there's a little LED right here on your that's going to come on. See, it shows you up there, just show you have it plugged in, and then that's your generator output. So look at that, man. Now, I have fairly large hands, but still pretty darn small. So if you travel and if you're a consultant or something, want to take your own scope so you don't get stuck with some crummy scope or whatever. Anyway, they have a special USB cable here. Pretty nice. And so, yeah. And then look at this. There's 4 packages of these scope probes. We'll pull these out, show them to you. But yeah, there's just 4 packages of this. Let's make sure. This is the first time I've taken all this stuff out of here, guys. Oh, I didn't. Okay, let's see what this is. All right, guys, that is pretty cool. I didn't know they sent you that. I like this poster because, man, you want to take a snapshot of that. It just shows you all the cool stuff that your scope does. Man, this is something I would put on the wall of your lab so you can just refer to it quickly until you're really super familiar with your scope. Man, glad they gave that. And then here, I've got one of these with my 5555 scope. So this is nice. The probes will all fit in that. It's pretty small. See, this guy isn't going to take much room. And then you got room for your probes, and you got room for this. So we're going to set it up, and we're going to take a look. All right, pretty cool scope. Witch's cap, the ground strap, plastic screwdriver for doing the compensation. All the different color of caps in there, pretty cool. I mean, the identifiers plus that little safety cap. This guy here, so you don't short when you're trying to touch, things close. See that little yellow guy? And there's one on it actually. So this one looks a little different, but basically the same thing. And yeah, nice scopes. And by the way, ×1 ×10, so that's a bonus. And there is a part number, TA375. So here we go. Just kind of show you this in case you want to see it. Here's your compensation. Here's your specs. All right, guys. So I'm going to plug it in and show you the software. And we're going to look at this stuff here on the scope again. And I'll show you the difference. I think I might make believers. I don't know. I became a believer. All right. We want to talk about specs. All right, guys. So actually, the McSig, I think, might beat out this guy as far as deep memory, which is kind of crazy but this one still has really deep memory. This one's still 64 megasamples, so that's still a lot. I mean, that's really close to the McSig, but just a little bit less. But I'm not sure if this divides down as much or not. I think it does. I think it divides the same way. It's 32 if you use 2 channels. So where that one was 35, this is 32. So they're neck and neck, right? All right. But I mean, look how small this thing is. This is where the signal integrity comes in. This is where your signals come in. This is where what you're trying to measure, right? All the other stuff is for the display, memory, and all that. There's memory on this. You know how small memory is these days. But anyway, your laptop's used for everything else. Okay, so the other thing, it's 4 channels, of course. So this guy also has 80,000 frames per second. So it's kind of like blinking, right? It captures all that data that we're talking, that deep memory and everything. It triggers, your scope triggers, captures all that stuff. And then it blinks, and then it does it again, and it blinks, and it does it again, and it blinks. So there's that little bit of a dead time in between, obviously. I mean, it can't trigger and then instantly even if it's nanoseconds, that's still some dead time. But there's not a lot. I mean, 80,000 is a lot. Now, I'd have to look at the specs on the scopes again, but maybe the McSig is maybe higher than that even. I don't know. But some of these scopes might have, like the memory on the MIG-SIG, they might have 1 or 2 parameters that, you know, just outstep this one a little bit, but it's all the stuff this one has in it that's so incredible. Okay, so the 1 gigasample per second, like all the other scopes have, horizontal resolution, this guy can go up to 10. So it's called real-time sampling, right? That's what all the scopes have. One real-time sampling, 1 gigasamples per second, right? 1 gigasamples per second, real time. But this guy, so on waveforms like we're looking at here that are repeating all the time, what this guy will do is he'll oversample. So it's called ETS, and that is just, you know, it's not the preferred thing, because if you have a transient that just happens, you want to capture it. That's real time. So if you have oddball transients happening every once in a while, your real time is going to capture that. But all the stuff that's happening over and over and over, you can go up to 10 gigasamples per second. So that's pretty crazy. That's amazing that you have that option, that feature. 10, that's a lot. Some scopes have that feature. None of these scopes, I don't think any of these scopes have that feature. But some do that I've used, and they go up to 5 or something like that. But this is 10. That's pretty incredible. The other thing the Pico software does, which I'm going to show you, as far as horizontal resolution, capturing things, you know, we're talking about, oh, we're missing some, you know, a transient or something. Maybe it triggers, you set it up to trigger on a transient. So let's say that transient's only 1 microsecond wide. It comes up 1 microsecond, it's gone. Okay, maybe it's 10 microseconds. Okay, but then maybe it's 10 milliseconds before it happens again. So that deep memory, you could try to capture that deep memory and capture 2 transients. But what this guy also has is he has a thing where he'll store 10,000 waveforms. So that blinks, he'll do that 10,000 times and capture all those. I mean, that'd be crazy to do that, but he will. And then often you're set up to 20, maybe 10, 20, 30, 40, something like that. And so you can, I'm going to show you this feature, but you can go back and look at the last frame, the last frame, like, oh, you know, like, what else did it capture? And so you can go back and look at frames to see if there's something else in another frame. So that's another really cool feature. Some of these scopes have what they call segmented, which is a very similar thing. But this one just is so simple to use. You know, that segmented thing, you have to kind of figure out how to use it and all that kind of stuff. This is just super simple. You just say, oh, I want so many waveforms captured, and it does. Okay? Like I say, some scopes will do that, but 10,000, that's a lot. I think another popular scope that just came out does 1,000, I believe it is. This 10,000. The other thing I'm going to show you on this, what this thing does, is it does the 8 bits like these scopes do, but it actually goes up to 12. So again, it can expand up to 12, and it kind of does that with oversampling too. So we're going to see how well that works, okay? But yeah, I did a video, 8 bits byte. You might have seen that, it wasn't too long ago. Anyway, watch that video, and I kind of demonstrate the difference between 8-bit and 12-bit. I think I might even show up 14-bit. So what does 12-bit do? So what 12-bit does is it instead of 256 samples, you get 4,096. Okay, so you get 4,096, and what that translates to, it's like 122 millivolts about. So yeah, 122 millivolts instead of 1.95 volts. So yeah, way better resolution, right? So if you're talking about tolerances and stuff like that, if you're only breaking up to 256, it's still pretty good tolerance. You know, hey, we've been using 8-bit scopes for a long time, but I don't know. I think it's just because the consumer, us, we're not, like maybe after this video, more and more of us are going to be demanding, hey, we want 10 bits at least, or 10 bits would be awesome, but 12 bits. Like, give us, how hard would it be to do 10 bits? Now, I'm telling you, the difficult thing is, what I was talking about, signal integrity, you have to have a super low noise, because if you're going down to 122 millivolts with a 500 volt range, you got to have very low noise to do that. Okay, so super nice. So what about FFT? Well, FFT, if you want to go down the dB level, that low noise stuff, well, if you can oversample, if you can sample at 12 bits, even if it's oversampling, now, like I said, FFT is going to be a cyclic thing too, right? Harmonics and so on. You're not looking at transients when you're looking at FFTs, not usually. So you're looking at repeating waveforms, which is what that oversampling, that 10 gigasamples per second is going to do for you. Also, the 12 bits vertical resolution. I mean, it doesn't seem like it's big enough to be that cool. But then again, I don't know. Girls like diamonds, and they're pretty small. All right, so let's hook it up. All right, guys, so this is the window that comes up when I start the Picoscope software, okay? And right here it says I have a scope that I can hook up to. And then down here is that generic scope, the one the demo that you can play with if you don't have a real scope. So you can download the software and use that. But anyway, we have this scope. So I'll click on that guy. Say, yeah, we want to hook up to that. I don't know if you could hear the clicking in the Picoscope, but there we go. There's our waveforms. Okay, so over here I have channels 1 and 3 connected. Okay, so I'm going to turn on this channel, and so what I'm going to do is I'm going to go to probes, and I'm just going to go to a standard type probe. I'm going to be hooked up as a 20x. See, I don't have 50x here as an option, but on this channel I think 20x is going to work great. But I could go down and do a custom thing and do whatever number I want. But I'm just going to choose 20 on this list just to make this thing easy. Okay, so there's channel 3, and then channel 1, I'm just hooking up the probes first, I guess. And this one I am going to be on 500x, so I'm going to need something different that's on this list. So in that case, I'm going to come down here, and I'm going to say I'm going to edit this one, okay? And so I'm going to say it's 500, probe name 500, so that's just a name, but then I'll know that I'm hooking up that probe and it's got to be on 500, and I'm going to use volts as my units, okay? Go next. And I could do the 500x right here. So that's what I'm going to do. 500. And then this table right here gives you values for what you just selected. Okay. Then you go next. Coupling mode. I'm going to start off with I'm going to go DC coupling. Auto range. I'll show you this, but I'm going to start off with this on. I'm going to start off with no filter. You can change these things on the fly, so don't worry about being locked into anything. And so there we go. So there's channel 1. I'm going to go back down channel 3. You see it says off. I want to turn this on, so I'm going to say auto. And we're going to stick with DC on that, and all this stuff looks good. Okay, so there we go. And I just click on the screen, it gets rid of that menu. So all right, so software. On the left, you got your channels, A, B, C, D, and then my generator. Remember, this guy has a generator built in too. If I click on generator, it comes up with these waveforms. So I can turn it on, I can change the type of waveform to any of these types. Okay, and here's an AWG if you want to generate your own. There's a white noise. So all the typical stuff. And here's an arbitrary. So I can go here and draw a waveform. I can draw it with these things. I can draw it with my, cursor. So it's very powerful. And you can import too. You can import a waveform that you've saved or whatever. And you can export one as well. So you can save this to something else and use it later. Okay, so I'll just go ahead and close this. So that was generator. So we got channels B and D off. Okay. So when I come over here on channel A, I just want to show you this. You got the vertical and you got all these settings, and it'll automatically set up your scope for you. Now, P-code's a little different. Instead of 5 volts per division, they say, oh, what do you want full scale? Plus minus 10. And so channel 1, we're going to be doing 500 volts. So I'm just going to go manual and say 500 volts. Okay. So say I got plus 5 and minus 5. And I really don't need a plus minus 5. I could go 250 and get a 500 volt scale, but then I got negative 250. So I'm going to go to 500. Okay. And then I'm going to say, oh, and by the way, you can do this DC offset too. So you can start off. So if I did want to go to 250 and use this, I could go offset minus 200, something like that. But I'm just going to do this for now. Actually, maybe I will leave it on auto just to show you that. Okay, and then probes. So here's the probes. We got this one times 500 down here. DSP. So we could put a filter on there if we want. Here's our resolution. This one I'm going to show you a little bit later. And here's the display. So here's scale. So I could change this to times 500 here if I didn't do it somewhere else. Okay, so right now I'm just going to leave that as 1. I can type it in here, or I can do the plus minus like this, or I can hit the middle and comes up with that menu. So it's really nice GUI. So there's your 4 channels in generator, and then you got all these things down here, which we could spend a day just looking at all these different things. But I'll show you the measurements. You got all these different measurements you can do, and even in FFT you can do a bunch of measurements. I'll show you that a little bit later because we will look at that. Okay, so there's measurements. Here's math channels, so you can do all this different kind of math. Okay, you can come down here and edit the waveform, and you can they got scientific functions built in, trigonomic functions built in. So here's some buffered functions. And we got filters too. You can filter things. And then a coupler. So if I have a different type of coupler, okay? You see that Cat 5? That was interesting, right? So anyway, so there's all the math. Then you can do a mask waveform. You know, you can generate mask from this source. So if that was our signal, that would be the mask. So it makes it really super simple to do this stuff. So we're not going to do that. Then actions. So what you can do is you say, when this happens, and you can give it a name here, when one of these events happen, we want to, here I'll show you the different things. You can play a sound, you can save that image. So if you just want to leave this and you're testing something, you're waiting for a glitch to happen. When that glitch happens, you say, okay, let's save it and play a sound. So I'll come over and see what happened. You can stop to capture. So this is super powerful right here. Probably haven't seen that before, right? Here's the type of events you can change. So here's on capture. If the buffers get full, then do this. If you're doing a mask thing, then you got these guys, but you can set these, you know, so this is really a powerful tool, right? So we're going to turn this off. We don't want to do an action right now. Click over here. So notes, you can make notes on your waveforms. That's super cool. So you got this tab down here at the bottom of the screen, if you see, and you can put notes down here, and I'll just click that and turn it off. And so I'm back to just measurements. Okay, so I'm taking an RMS measurement right now. You got rulers that you can put on the screen and see these. You can set up these rulers so if anything happens within these bounds, phase rulers, so there's phase stuff. So really powerful tool. I mean, there's things here that you're like, oh wow, I've never seen that before, right? Or maybe you have and you're like, wow, okay, this little scope can do that too. Here's deep measure. This is another whole thing where it'll capture a bunch of information, just tons of information, and you can go analyze it later. Okay, So it's like taking a whole bunch of measurements, and it's pretty cool. Anyway, I'll have to show that in a video someday. And then more. Let's hit the more screen. So more, I'm just showing you this. Some of these things are repeat what I just showed you, and some are new, right? Settings and that. So here's settings. So here's where you can change your screen. If you want a light screen or a dark screen, okay? You want the panel on the left, or if you want to switch over to the right side. Hit left again, come back over here. There's left, okay? Trace thickness, your metrics. So you can see there's just a lot of, and then here's user settings, here's last session. So this is where, if I'm taking measurements and I want my scope to come up when I turn it back on again, to come up the way I had it set last time I used it, then I want to do that. If I don't care, I could just use factory. Or if I wanted to, if I wanted to come up in a default configuration, I could do factory. That way I know where I'm starting all the time. Or I could do user. Like, I want it set up a certain way every time it comes up. So I'm going to say, yeah, this is what I want. So these are, very useful settings, right? Right here, I kind of saved this one for last. Views. I'm going to show you this in more detail as we go along. Okay, we're going to take some measurements, but views. I can say, oh, I want to see the spectrum of these traces, so I can hit this. And look, now I got the spectrum down here. Isn't that amazing? Oh, I want to look at the spectrum again. But now I want to show you something. It was confusing when I had both these trace channels on the same spectrum. So if I highlight this one, like right there, okay, and go back to views. So this is highlighted. I can highlight it going this way too. This is the way I really want to do it. But you notice down here, show hide channels. So on this channel, I just want to see A, okay? But on this spectrum, I just want to see C, so I'm going to turn off A. So there we go. I separated my two spectrums. Isn't that super cool? We're going to use this feature in a moment, okay? And you can change the names of each one of these spectrums. So I could say drain of MOSFET Q1, like Q1 drain or something like that. Q1 gate. Here's an auto range as far as the layouts, and obviously a reset. So if I hit auto, what does it do? You can set up a bunch of windows and it can get kind of crazy. And here's your XY function. May as well show you that while it's here. See how this window's a little small? It's because I have these. I'm going to turn these guys off for now so we can look at this so closer. This window right here, let me see. Views, when we're in our XY, we can put a name again, change that channel, display XY view at 1:1 aspect. That's a square, okay? So if I turn off this one up here, I could get the square to go bigger. But I could turn this off, and then it just fills it up this way. So you're not going to get that nice XY square display that you might want, but you might not care. So you can, use the full width of your screen by doing that, okay? So we're back here. Okay, so I kind of showed you all this stuff. Oh, and then see this AB? See, I have my math and all this stuff set up here. I can come over here and click on that and then delete it so it gets it off this little one. The reason it does this is you might want to turn on and off these features you set up, and you don't want to lose them, all that setup time. So it saves them here for you. But I don't. Okay, guys, so we've gone through the channels, a bunch of stuff over here. Down here on the bottom where it shows the measurements, I'm going to put some more measurements here, but I want to show you this. If you want to get the screen to fill up more and you only want to know just the RMS volts, you can do that. The medium size gives you these statistics as well, and just a little more information. And then there's the large, which I think they think you feel like you need large. You want to be able to see it better, so they don't put all the other information. They just put these numbers real big. Kind of humorous, actually. So I usually just do medium unless I put a lot on there, then I'll go to small. But and that's the other thing, by the way, you can put lots of measurements. I don't know, I've never hit the boundary where you can't, like some scopes only let you do 6 or maybe up to 8 even. This one, I don't think there's a limit. All right, so here we are. We're looking at the screen, right? Now, here's channel 1 on this side. Here's channel 3 on this side. And across the bottom is the time, okay? So time is up here, the scope, this is your horizontal. And I could go, right now it's 500 microseconds per division, so I can hit minus or plus that way. And the screen's turned off, so I'll just turn it on. But minus or plus, or I hit in the middle, and it comes down with this. First I have time base. I have 2 tabs. I have time base, and I can go select what time base I want, so I don't have to hit plus or minus. I can just jump to something. I can also go to this A to D, and this is where I can change my sample rate. Look at this, target sampling rate, 10 gigasamples per second. So that's just nuts. This progressive mode is another thing that's really interesting. I'll just hit this. So it says at this time base and longer, display partial trace until all samples are collected. So there's different time lengths you can set here. You can see we're kind of at the minimum right here, 100 milliseconds, so it updates pretty fast. If I keep going this way, pretty soon you'll see how it slows down. So this is something you can play with if you find that you want to do that. The buffer memory, you can go here and change how many samples and all that kind of stuff, progressive mode. But sample rate is here. So the buffer, it's just a memory that holds information before it transfers it, right? So I just wanted to point out that you have those 2 things. And if you look up here at the top of the screen, the sample rate right now is 500 megasamples per second. So those are the maximum values I set, and then it'll set what is required for down here, okay? So it's showing you the information there. And triggers the same thing, plus minus. So here's the trigger right here. See how it looks kind of funny? I want to show you that. So I can go plus minus, change the value. See, I can move that around by doing this way. But if I click on here, what I did is I have this advanced edge. I'm just going to go to basic sample edge, okay? So that's just your basic sample. And there's my trigger. See right here in the middle of the screen? I can grab it and move it around wherever I want to trigger. I can go, oh, I want to move my trigger right here. So I can move it around that way. I can put, wherever I like. Or I can do it by this. If you notice, when I moved it, those numbers change. 31%, 2 volts. It's up here, 2 volts. See, 2 volts on the vertical right here. And it's also on source A. But what if and B and D are kind of not highlighted, so I can select C if I want. So now it's on C, the green one. See the green glitch right there? So I can move that around and assign it the way I want right here, okay? And also it's on automatic right now. There's all these other modes. I can't explain all these things right now because it's, yeah. I mean, you can see that there's a lot of power here. But, okay, but I'm going to show you more about the trigger in a moment when we have a real signal. So we have the trigger, and then here's the waveform thing I was talking about before. Right now, I only have it set for 1. If I click on this, see, there's only 1 here. I could say, oh, let's do a few more. So I'll set 5. And now, see, this is stopped, so you don't see an update right now. I got that going. Now, if I click on the waveforms again, see, there's my 4 waveforms, okay? So I can turn those off right up here, but I could jump over to this screen like, oh, what's going on there? Or I could say, oh, no, I want to come over to this screen or this screen. So that's those waveforms where you can capture a whole bunch if you want, but it's just up here. And capture time, you put the time where it actually captured it or turn it off. Maximum waveforms, I got on 4 right now. I hit this I and it gives you some information here. Okay, so I just click on the screen, get rid of that, and then come up here and I'll get rid of that. So that's waveforms. Then over here's instruments. I'll show you that in a moment. Here's auto setup. We know how that works, right? I can just click right now. I don't have anything going on right now, so that's what it's doing. So you can open files here, You can save files. Here's your print and here's your full screen. So if I do full screen, like, oh, okay, I want to see that. If I come to the top screen, it gives me this thing again, then I can turn it off. And I have an update over here. I got to show you guys what an update looks like on another video, but I won't do it right here. Okay, so instruments. I saved that for last. This kind of looks like that view thing, right? But this is different because now if I click on this, it just changes my instrument to a spectrum analyzer. So like the GW Insect does. So now you have this spectrum analyzer, and I can show you. See, it's 20 kilohertz per division. So it's super simple to set up. 10 kilohertz per division. You know, super easy. Okay. Let's see what I can go to. Now you notice every time I go to a higher frequency, it's rising up here because the noise floor, I'm getting more and more noise as I go to these high frequencies. Now, I'm going to show you more real. Okay, let's go look at some real signals now. Okay, I just wanted to show you these setups, and also if I click on the middle of this, see how my spectrum, there's a start stop. I can do it that way, just like a spectrum analyzer. So I can go to bins. Bins is how many it's taking samples. It needs 2 samples per bin. So here's my bins, and I got to collect a bunch of time. See, it says 6 milliseconds to do this, but I could go to a lot more bins. Okay, 1 million bins. So it's going to slow down, but you notice how the noise floor drops when I do that? Because I'm getting more and more accuracy. So I'm going to show you some more stuff on this in a moment. Here's the different types of filter, or math functions you can do. So I was going to say filters because that's kind of what they are in my mind. That's what I think of them. Y-axes. So we're looking at peak. I could do average, which is kind of a common thing, right? And so you see how the average looks a lot better. You kind of see some peaks in there. So I'm going to leave it there. I had it on peak before because I was looking at something, but you see how it jumps up. The average is a better thing because it gives you a better picture, I think. And then you got dB volts and all these other things. You can do an arbitrary dB if you want to. And axes right now is linear. I could do log if I wanted, and I can say how many decades in log. So super powerful. Go back to instruments, and here's your XY. So back to XY again. So that's where your instruments, you can select to change your scope. So essentially it's a mixed domain scope, just like the GW Insect is. So I mean, I feel for half the money this scope was just so much more, that in my opinion. All right, guys, I'm gonna turn on the converter. You're gonna see it come up, okay? All right, guys. So now what we're gonna do is we're gonna turn on the flyback converter. Got my little blast shield here. We're gonna turn it on, capture the waveform, and I'll show you the difference here on this scope, okay? So let's go ahead. I got that turned on. I'm gonna crank it up. Okay, we'll see the signal here pretty soon, and there it is. Okay, I'm going to go ahead and freeze it like I did before on the mixed sig. Okay, let's go spread it out and take a look. Okay, so as we spread it out, well, here, what I'm going to do is I'm going to use this window. See, this cool little window you can move around. So I'm going to use this, and I can go this way, plus, I could do it this way, or I could zoom in this way. Or I've got this highlight, this hourglass there, that magnifying glass, so I can come in here and do it that way. And I say, okay, yeah, that looks like what I want. So I'll go a little bit more, and I got this hand, so I can click on that hand right there, and then I can move this waveform up. Okay, no, yeah, that looks all good. And if I look over here on the left, I could grab this waveform and try to put it right on the line. Like there, get a 0 crossing, and I could do that over here too. I say I'm going to put it right here, whatever. Okay, so there's my 0 crossings on the left and right side of the screen. All right, my zoom window. So let's zoom in horizontally some more. I'll hit the plus sign. And I can also grab this thing up here. You see how it goes to a cross? When it's like that, I can grab this and move it across the screen. I'll try to get over by the... it's going to be kind of hard. I was trying to find the trigger. But anyway, right around there somewhere. Doesn't matter. You can see the trigger right there, that little yellow dot in that waveform. That's the trigger. But yeah, there's waveforms. So let's print it out even a little bit more. So I can see the edges. Now look at this waveform. It looks, instead of just a flat top or whatever, it looks a little different, right? The green waveform up here. The blue one's rounded, but it's got a little bit of spiky stuff. So it looks like there might be a little bit more information. Now, over here, you see the ringing that we saw in the mix sig? So we can zoom in horizontally, just like we did before. And it's a lot like the mix sig, right? Maybe even, because I got this thing over sampling, so maybe even a little cleaner, right? I mean, it's pretty darn good. Here, let's pull this over. Pull the waveform over. If I pull it in the middle of the screen, and then if I go plus, it stretches it around the middle of the screen. So yeah, it's probably smoother because I'm getting those extra oversampling. That's where that helps in this scope, I think. Now, alright, so horizontal looks pretty darn good. But again, if we try to zoom in on say this ringing right here, look, I'll go back to this magnifying glass. I'm going to say I want to zoom in right on that. I'll capture the blue waveform too. So I just want to zoom in on that. And it actually looks fairly smooth, huh? So, yeah, it actually looks pretty smooth. Alright, that's impressive. If I go to channel C, I want to look at the DSP, and we are on 8 bits, but man, the vertical resolution actually looks pretty darn good. Okay, so let me go back here, and you can do this undo button, so I'm going to do that. Go back to this. And I want to come up here and look at the top of the waveform, because there's a little bit more high frequency than that. Yeah, so that's looking a little bit more like the mix sig maybe, where you see this kind of digital chunky choppy stuff, right? Okay, so here's what I'm going to do. I'm going to put it back in trigger mode, okay? So it's running, and I'm going to turn back. So what I'm going to do is I'm going to turn this wave back on, and when I do, I'm going to leave it real time this time, and we're going to see if we can fix that. Okay, so see it right there? Alright, so see how it's kind of just jumping around? I mean, it's chunky looking. So if I go to A, see if we can fix that one. I go to DSP. I can do this, go 8.5 bits. And it slows it down a little bit. Looks a little smoother. Yeah, it's looking a little smoother, not that chunky stuff. So let me zoom out just a little bit. Maybe a little bit more. Yeah, so a little bit better, right? So that's 9 bits. So let's go 9.5. Okay, it's looking better, right? Now it's having to do a little more processing, so that's why the update is a little bit slower. But now look, if I go all the way to 12, look how smooth that is. So I want to tell you, this is kind of a trick. It actually, if you go too many bits for your, like what we're capturing up here. Okay guys, what I'm going to do is I'm zoomed way in, and horizontally and vertically. So that's, I didn't do that with the mix sig. I kind of changed it up. I changed it up so we were just, I went to 2 microseconds or something like that, right? So let me get rid of the zoom window for now. And let's do the same thing here so we can speed up the time a little bit, because I'm capturing a lot of data. So this is what I did on the mix sig, right? I did it this way just to see if it got any better. By the way, you see the trigger? It seems like it's better, right? So this is a digital trigger. Now watch, I want to show you something. It doesn't seem like, wait, hold it. Before we do this, let me bring this trigger. What if I was trying to trigger down here? That's actually still good. Now, I was trying to go to, wow, this is unbelievably good, I think. Let me go back at a trigger. I wanted to see if I'm triggering on the, yeah, I am, I'm triggering on the blue one. Let me trigger on the green one. I think I can make it look a little worse if I do it that way. Yeah. Okay, whoops. I gotta go back. Okay, we'll go right there. Okay, so let's see. I'm triggering on the green waveform now. Now if I come down here where it's crossing over, God, it's still looking pretty darn good. Oh, it switched. How come it switched? I want to trigger on C. Did I do that? Okay, it's on C, which is the green one. But wow, I'm amazed at how well it's doing. If I thought if I came down here where it's crossing 0 a bunch of times, it would do worse, but wow, it's still doing great. Okay. When I'm looking at Class D amps, certain things, it makes it harder, but you see how it's modulating a little bit? What I wanted to do is I wanted to show you, you can go to this trigger type and advanced edge, okay? That's this advanced thing. And what that does is it gives you this hysteresis thing. So if you look over right, see that line dropping down as I increase the hysteresis? Here's the threshold, -4 volts. You know, that's, I could put it at 0 volts, whatever. This thing's not on 0 anymore because of my zoom. I just put it back to 0. I'll put the green one up here on 0. Maybe even up here. I don't know. Put it right there, I guess. But anyway, see this line here? This will help you if you're having jitter problems. So once it crosses this line, it has to drop all the way down to here. I see these wiggles. If we were down here triggering, the first time it crosses 0, it would have to go past this to trigger again. But man, this thing's holding really steady. Now I could grab it and I could drag it down too. And you can see how it changed it over here. So anyway, these digital triggers are really amazing. It turns out this thing's triggering really rock solid. So, alright. So now we got this. Now let me use this guy again. I'm going to go ahead and stop this just so I can turn down the power supply and not worry about things blowing up in my face while I'm thinking about 10 things. Okay, so I'm going to take this and I'll move it right here for now. And I got the magnifying glass on. I'm going to zoom in on this ripple right here to take a close look at what's going on there. Okay, there's that chunky stuff. Now if I come here and, okay, hold on a sec, sorry. I actually have to be real time when I'm messing around with this, so I guess I got to turn on the power supply again. Alright, so go to DSP and we're going to go up in bits. 8.5, there's 9 bits, and there's 9.5, right? Now, if I continue this like I did before, it actually smooths off. It actually does the opposite of what you want. Instead of getting better resolution, what's happening is we're losing bandwidth of the scope. Because as you do this, your bandwidth drops in the scope. So it's a little trick. You want to go from 8 bits down just enough to where you don't see square, like clunky stuff going on. Yeah, see how it's clunk, clunk, clunk like that? So you want to go just enough bits where it goes more like that. But if you go more, so I'm kind of on the, you know, preface this, right? I'm like, if I go a little bit more, I'm getting to the point where I might be filtering, but maybe it's easier to see. So it's one of those things where you kind of have to play. See, if I freeze this, it looks pretty good, right? There's a little bit of a chunk right here that I missed. I didn't get the resolution right there. And maybe one here, but so I think you kind of get my drift. You got to get that 9.5 bits. It's about 9.5 right here. Okay, turn that on real time again, and I'm going to turn off the zoom because I want to look at something else. Let's look at. I want to look at the top of the blue waveform. Okay. So let's hit the zoom, and I'll just capture this. And now the blue waveform actually looks really good, right? Let's go see where we are. Okay, we're at 12 bits, that's why. So now let's back it off. And you notice how it got wider? Because when we were filtering, here, let me do this. When we were filtering, we actually filtered some of this signal. That's a giveaway. Okay, see if you get what I mean. If you're filtering this, it'll slope in because you're filtering. And so when I started backing off the bits, you see how it got more square? So let's do that some more. 10. Seems like this frequency, 9.5 seems to be a pretty good one. See, this looks kind of digitized, what I call it, right? If I freeze it, you see what I'm saying? It's all chunky looking. If I zoom in vertically, use the hand, pull it down here. See what I mean? So here, let me spread that out. Whoops, wrong way. Grab the hand, pull it over here. Yeah, see how chunky that is? Okay, let's go real time again. And let's zoom out again. And so we go 9.5. And look, it looks more spiky, less chunky. If I freeze that, there's just a little bit of squaring off, but it's mostly smooth. That's the difference. When you see nice smooth sine waves versus like, oh, like it captured a bit here, missed one here, so it drew a line between them, so it looks like a chunk. So real time, if I go 10, okay, so maybe 10's the right one. So when you're trying to read a waveform, you want to get the right resolution where you can see the shape and the frequency, and a lot of times what you're trying to do is see what the frequency and the amplitude is. So yeah, you kind of have to just find the area where you just barely go away from the chunky, or maybe a little bit chunky, and then you still got good horizontal resolution. So you just lose some resolution bandwidth as far as horizontal bandwidth when you're trying to get really good vertical bandwidth by oversampling. Okay, so yeah, I just want to point that out. But look how great that is. Okay, so I'm going to go with 9.5. I'm going to go where there's just a little bit chunky. Okay, and I mean, and the other thing, let me freeze this for a moment. Look at this, 120.7 volts. 122.7, 124. So this is like 2 volts per division. And we're seeing all this resolution. That's at 120 millivolts resolution with 12 bits. But we don't have 12 bits, but we're still getting pretty amazing resolution. I think that oversampling horizontal and vertical is giving that. I think that's why it looks so good. But let's turn that back on. I'm going to get rid of the zoom window. Okay, that looks great, right? Both those waveforms look great. Let's go back to, let's add a view. And let's go to spectrum. There we go. And you know what? I could add 2 spectrums, right? I add one more. And since I added 2, because what I thought I could do is get rid of C on one, and I'll go to that one, get rid of A. Okay, so there we go. This is running real time. You can see it up here, and kind of crazy. Now I think I need to get some more waveforms to get some more resolution in the FFT, or in the spectrum. So see that? Now we're starting to see more definition in here. So we can play around with this. The other thing I thought is, you know what we could do is I can get rid of these and go to spectrum here and just go, I don't care about the time domain right now. I want to look at frequency domain, so I can go here and then look at that. Now this is here, let's see what we're at, 8.9 megahertz. So pretty high resolution. We could go all the way up to 70 meg, it looks like. And wow, there's something going on over here at 65 meg or whatever that is. I can go to my rulers, they call them rulers, and turn these guys on. Drag that over there. Whoops, move it out of the way so I can see where the peak is. Another thing I could do, I could just zoom in on this just to see what the heck that is. Take this window, put it up here, take this window, put it over here. And yeah, so, and by the way, these rulers, I've got them up here, so since I zoomed in, I only see one, right? One of them's at 62 meg and the other one's off the screen. It's over here at 14 meg. So I could come up here and say, put that at 62 megahertz. And you see how it jumped over? Isn't that awesome? So I can move that right here and say, okay, what is this frequency between? Because what it looks like is this one in the middle is some harmonic. The ones on the side are beating against this one. And yeah, so look at that, 275 kilohertz. So the frequency between these is a switching power supply. This guy right here in the middle at 62 meg, I don't know what that is. It could be, yeah, it's hard to say. But something is causing a spike at 62 meg. And then we have the frequency of the modulator, the flyback converter, beating against it. So you see one on the minus side and one on the plus side. If I move this over, it's going to be about 500 something kilohertz between these two. 563. Move this guy over, it'll be that switching frequency again. So yeah, and then see this guy? He's another one. See, 274. I mean, if I was zooming in and putting these precisely, I think you see what I mean. I'm guessing it's this one. There's another one right here that's harmonic of something. Yeah, 281. So yeah, interesting, right? So you can see, and then there's stuff going on here. So there's lots of information, lots of things you can learn by playing around with this. Pretty cool. All right, guys. So what do you think? I mean, it's pretty amazing. This video is long. Sorry about that. I'll stop talking real quick. Thank you very much, Picotech, for sending me the Picoscope. This again, it's part of the 2000 series. There's a whole price range, and this is the 2407B. So pretty darn nice. It's under $1,000. I think the list price is $979 with everything you saw, with the probes in the bag and so on, with what I got here in the box. So it's neat because you keep on getting updates in software. Your scope's not going to be outdated. If you want a bigger screen, you got it. I mean, that screen's huge compared to these screens. And this is a small laptop. It's I think that's a 13-inch MacBook. So yeah, and everything's right there on your laptop, so you save all your images. It's just really nice. It runs on USB power, so it's not running on the 120 volts or your line power, whatever country you happen to be in. So it's nice. It's still tied to that voltage, the USB power voltage that's coming in, so you still have to be conscious of that. There is an isolator for the USB power, so you can isolate your scope from your laptop. Laptop's just floating. It's not connected to AC power either. I mean, I actually have it tied right now. It's being charged through USB, which has also got isolation from the AC power. So anyways, there's a lot of neat things about it. God, it's pretty amazing, I think. And again, that thing costs around $1,800, and this is essentially an MDO2. It does the same things as that guy. And in my opinion, if I would have been more knowledgeable about, if I would have known about Picotech before I bought these scopes, I'm sure I would have got one of their scopes a lot sooner. But yeah, nowadays, I mean, this thing's small too. It's just sitting here on the bench. It's just little. The laptop's big, you know, but man, what do you guys think? Now, I've seen some people operate these with full-on PCs and that they put underneath the bench. They put a screen on the wall, so they have a big old screen to look at. So yeah, you can set these things up all different ways, and then that way it's not taking bench space at all. But man, it doesn't take much room to put up by the differential probes, and I just really happy. So looking at the specs, I still feel like under $1,000 it's pretty hard to beat. I would like to hear in the comments what scopes you'd like me to compare it to, and you know, just side by side. I'd be interested in that. Thanks for watching, guys, and hope you like this. Sorry for the long video, but for a scope that costs this much, I think you really want to hear the details that I have, or you know, anyway, a short video might not give you enough information. Might just kind of, you know, wet your taste buds, right? And then you're like, oh, I just need to learn more. So hopefully I went through enough that if you're interested or have been interested, that I gave enough information here. So thanks for watching. 2 thumbs up to my patrons, as well as 2 thumbs up to Picoscope, Picotech. And yeah, and you guys hit the super thank you button down below. I gotta start putting names up. I gotta do that next video. Throw some names up, some people that have used that. Really appreciate that. Yeah, you can always join, support the channel using Patreon. The link's down below, or is a free way to support the channel, and liking the video is a free way. So appreciate it, guys. Thanks for watching. We'll see you next time.